All right, last page. 41 through 43 go together. In the scale diagram, two forces, F1 and F2, act on a 4 kilogram block. So they're telling us the mass of the block at point P. Force 1 has a magnitude of 12 newtons and is directed to the right. We don't know what F2 is. Using a ruler and a scale diagram, determine the magnitude of F2 in newtons. So it says this is drawn to scale. So I basically have to measure this distance here and convert that to our scale. So it looks like 4 centimeters. So this equals 4 centimeters. It won't let me write the word centimeters. So you get 12 newtons per 4 centimeters, or 3 newtons per centimeter. If I go back and measure what F2 is, it's roughly 3 centimeters. So I believe F2 is 9 newtons. You don't have to show your work on this because it's only worth 1 point. Determine the magnitude of the net force acting on the block. 12 newtons in this direction, 9 in this direction. F net is 3 newtons. Again, no work to show because it's only a 1 point question. Calculate the magnitude of the acceleration of the block. Show all work. So the equation is that. Substitution with units. Whoops, let me undo that. 3 newtons equals, it said it was a 4 kilogram block times A. A is equal to 0.75 meters per second squared. So equation, substitution with unit, and an answer with units. So that was pretty easy. The instant before a batter hits a 0.14 kilogram baseball, the velocity of the ball is 45 meters per second west. That's important. This is V initial. The instant after, so this is going to be final, hits the ball, the velocity is 35 meters per second east. We have to decide which is positive and which is negative. I'm going to make east positive and west negative. Usually we do that. The right is positive. The bat and the ball are in contact for 1 times 10 to the negative, so this is the time. Determine the magnitude and direction of the acceleration. Acceleration is change in V over change in T. It's V final minus V initial over T final minus T initial. In this case, V final is 35 meters per second east. That's where the plus comes in. V initial is, and this is just the minus from right here, V initial is 45 meters per second west, but west means negative. And our delta T is 0.01 seconds. That's what 1 times 10 to the negative 2 is. Move it 2 decimal spots. 1, 2. A negative minus a negative is the same as a positive, so I get 80 meters per second divided by 0.01 seconds is 8,000 meters per second squared, and it's a positive. The positive means, I think I showed it over here, that means east, so east. So the magnitude is 8,000 meters per second squared. The direction is east. And we can box those answers. Calculate the magnitude of the average force the bat exerts on the ball. F net equals MA is my equation. Again, on this last one, here's my equation. Here's my substitution with units. Here's my answer with units right there. Here, F net equals MA. The ball is 0.14 kilograms times 8,000 meters per second squared equals, I don't know what that is. Use a calculator. 8,000 times 0.14, 1120. 1120 newtons. Equation, substitution with units, answer with units. Okay? Last question. Student on building X is located 240 meters. So here's your student over here. From the launch site B of a rocket on building Y. So there's a rocket over here. Student's eyes are level with the launch site. Good. Using the scale diagram and a protractor, I wrote in here the scale. I hope this is right before I made photocopies. 1 centimeter is 45.5 meters. Measure the angle of elevation. That's pretty easy to do if you know how to use a protractor. I can't show you on the test how to do it, but I got about 31 degrees. Again, there's no work to be shown here. I bet it was supposed to be 30 in the original drawing, but whatever. Determine the height h of the rocket above the student's eye level. Again, it's all scale. When I measured it, I got 3.3 centimeters. So if I multiply that by 45.5, I got 150 meters was the height. What is the total distance the rocket must fall from its maximum altitude? So this is the maximum altitude, so the total distance the rocket must fall is 150 plus 100 is 250. This seems very easy. Determine how much time is required the rocket fall freely. So this is a kinematics question. We know the distance that it falls is 250 meters, but the displacement is negative 250, right? Negative 250. We know A is equal to G is negative 9.8. The negatives there mean down. V initial, you know V at the top here is 0. So if we're solving down, V initial is 0. And the time is what we want to know. I think we want to use D equals V initial. T plus 1/2 AT squared. There's your equation. Substitute negative 250 meters equals, this is 0. 1/2 negative 9.8 meters per second squared times T squared. T is equal to 250 times 2 divided by 9.8. 7.14 seconds. And we're done with this test. Good luck tomorrow.